All right, welcome to part two video on solving quadratic equations. We're going to jump right into things, not so much explanation as the last video. And so first thing I need to do is make sure that the quadratic equals 0, which it does, so then I can begin my factoring process. So if I take 3 times 9, or a times c, I get 27, and I need two factors of 27 that when added together equal 28. So that would be 1 and 27. All right, then I'm going to write those as two binomials. So we get x plus 1, x plus 27 equals 0. And then what I need to do is then divide by a, because a is a number other than 1. And so I'm going to divide both of the found factors by the a. And then I'm going to simplify. Now we notice that 1/3 is already simplified, so I'm going to drag the number up front here. And then 27 divided by 3 is going to be 9. And so I have my factored quadratic. This allows me to use the zero product property, which states if I can make one of these binomials equal 0, then I have found one of my solutions. So I go here, x plus 9 equals 0. And again, a two-step equation, really quick. We can just solve for x. So we get x equals negative 1/3, and we get x equals negative 9. Okay, I didn't put up the Desmos yet, so if you want to, plug those into a graphing calculator or to Desmos, and you'll be able to see that, that this is this place where the parabola crosses the x-axis. All right. So now I'm going to jump into a couple unique cases that you may see. In this case, the a is negative. Okay, so if you by chance are changing terms around, solving for or getting 0 on one side, you may run into this thing. My recommendation to you is that you try to keep your a as a positive, just to create less confusion when simplifying. But let's talk about that now. Okay, so right away, I'm going to take, I notice that it's already equals 0, so I don't have to worry about that place. So now I'm going to take a times c. So two factors of 6, negative 2 times negative 3 is 6. That would equal 7. Now in the last problem I didn't tell you to stop, but if you want to stop the problem now, work through it and then see how you do compared to mine, you can do so now. Otherwise I'm going to continue working on here. So two factors of 6, that would equal 7. That would be 1 and 6. And then I'm going to write that as two binomials, x plus 6. And then again, I'm going to put that equals 0 at the end. I'm going to divide by a. Now in this case, it's negative 2. Okay, so that's going to, I got to make sure I incorporate that into my simplifying here. So that would simplify to x minus 1/2, because it's 1 divided by negative 2. And then this one simplifies to x minus 3. 6 divided by negative 2 is negative 3. And this is why I caution the idea of using a negative as a, because sometimes people forget about that. This needs to change to a negative, and this changes to a negative. All right, and so we know that we got to move this up to the front. So this becomes 2x minus 1 and x minus 3 equals 0. And then we're going to use the zero product property. We have the nice binomials here. So we got 2x minus 1 equals 0. And x minus 3 equals 0. And then we just solve here. So 2x equals 1, divide by 2, x equals 1/2. So that's one of my solutions. And then if I add 3 real fast, I get 3 is one of my solutions. Now, I encourage you guys that if by chance you just happen to move the terms over and your a becomes negative, a quick fix you can do is just really multiply both sides times negative 1. So if you multiply all these terms by negative 1, it doesn't hurt anything. It actually makes your a positive. So that would be 2x squared minus 7x plus 3 equals 0. Now if you want to attempt to, try that problem out, you're going to see that you get the exact same answers here, but just maybe a quick way to make your a negative is just to multiply both sides times negative 1. Okay, example 3 now. This one's a little unique because it is a binomial. Okay, so I'm going to show what happens if we're missing that b. So really, I do the same steps I've done before. I make sure that the quadratic equals 0, which it does. and then I'm going to take a times c, so 2 factors of -9 that when added together, and notice how there is no b, so I need 2 factors of -9 that would equal 0. Well, in this case, that would be 3 and -3, and I'm going to put those as 2 binomials, equaling 0, of course. And then we're going to divide by a, simplify. Don't forget to simplify before you go any further. All right? And I'm actually going to teach you guys a quick trick. Like, we can look at this. I mean, we can move the 3 up in front, but let me ask you just a quick question about what would make this equal 0? Well, the opposite of this side. So I can maybe take a step out of the problem by just saying, well, anything its inverse, or not its inverse, its opposite would make it equal 0. So -1/3 plus 1/3 is 0. And then, of course, this one would be +1/3. Okay, so if you're watching this video, you just learned a quick trick to maybe save yourself some time. Again, we could move the 3 up in front, 3x plus 1, 3x minus 1, and solve, or it could be just an observational thing. And if you notice on this one, like right here, you say, oh, a half could be my solution, and 3, and so on and so forth. -1/3, because that's the opposite of +1/3. So it kind of eliminates maybe this extra step, but I do want to make sure you understand that we're using the zero product property to solve these quadratics. All right? Thank you very much.